question number 40. At no load condition, a 3-phase 50 Hz lossless power transmission line has sending end and receiving end voltages of 400 kV and 420 kV respectively. Assuming the velocity of traveling wave to be the velocity of light, the length of the line in kilometers is dash. Okay, so let's first write down what's given to us. We have been given the sending end and receiving end voltages here. So that's Vs is given as 400 kV and Vr is given as 420 kV. Now the question talks about no load condition. So at no load, we need to remember the relation that Vs is equal to A times Vr. Now A is a constant, okay? A is a constant. Let's find out what A is first. So Vs is equal to A times 420. Vs is 400. So from here we can find out what A is. A is 400 divided by 420, which is 0.9524. So now we can write down the equation for A. When we are talking about no load condition and transmission line, A has a formula which is 1 plus yz divided by 2. The admittance times impedance divided by 2 plus 1 will give you what A is. So these are a few relations that are important and you will have to remember. Okay. So A is a constant with respect to the impedance and admittance. Okay. Right. Now the next step is to expand this. Let's expand this in terms of inductance and capacitance. That's our next step. So A would be equal to 1 plus, now the admittance can be written as R plus j omega L into G plus j omega C divided by 2. Now, since the question says that it's a lossless power transmission line, it says lossless. Now, for a lossless power transmission line, R and G will be 0. So if R and G are 0, we would be left with 1 plus j omega L times j omega C divided by 2. And j square is anyway minus 1, so we can just substitute that. Here, let me show you. So we have A is equal to 1 minus omega C times omega L divided by 2. Now the next step is to write the equation in terms of phase shift constant and the length. Okay. Now we have another relation. Beta L is equal to root of omega L into omega C. Now here's another relation that will help in deriving the expression that we require. Now here beta is known as the phase shift constant and L is the length of the line, length of the transmission line. Okay, so if we were to square on both sides, if we square it on both sides, we get beta square L square is equal to omega L into omega C. Omega L into omega C, we can substitute it in terms of beta square and L square right here. And we would get A is equal to 1 minus beta square L square by 2. Let's substitute the value for A now. We have A is 0.9524 is equal to 1 minus beta square L square by 2. Now the reason I have brought all of this up is because we require the length of the transmission line. So as many relations that you can remember, it's good to keep them in mind while working on this, because you will have to use some relations in order to substitute them and get it in terms of the unknown variable that we are looking for. Now because we are looking for L, I used this formula here and then substituting that in terms of A to get this. So let's cross multiply and try and get it in terms of beta first. So here we have 2 into 0.9524 is equal to 2 minus beta square L square. So solving this even further, we get beta is equal to 0.3085 divided by L. Now I'm writing it in terms of beta is equal to 0.3085 divided by L, so that we can remove beta. Now beta has another formula. Now here's the next formula. In terms of the velocity of the wave, here, the velocity of the traveling wave, you see in the question there. So in terms of the velocity of the traveling wave, we can write it as velocity divided by f is equal to 2 pi by beta. So all of these are quite interesting relations, in fact. All these relations will do good to remember them. Now let's substitute beta's expression here, because we know what the velocity is, we know what the frequency is. The velocity, according to the question, is given as the velocity of traveling wave to be the velocity of light, right? So from here we will be able to write the expression for beta as 2 pi f by v. 2 pi f by v. Let's substitute that over here. 2 pi f by v is equal to 0.3085 pi L. Okay, right. Now let's find out what L is. I'll write that down here. L would be equal to 0.3085 into the velocity of light divided by 2 pi f. And that's 0.3085 into 3 into 10 power 8. This is a value that you must remember, divided by 2 into 3.14 into, we have 50. Okay, it's given that is 50 hertz, so it's 50. Solving this, we get 294.745 kilometers. Now once you solve this, you will get it in terms of meters. Please remember, 294,745 meters. You convert that into kilometers because the question asks for kilometers. So here this is our final answer. 294.74 is the final answer. I hope this has helped.